Hello again, Dylan. So here we're going to take a look at the rational root theorem. And the example I have is from your book. We've got 3x cubed minus 4x squared minus 5x plus 2. The 2 from the rational root theorem is going to give us possible numerators. And it's factors of 2 we'll look at. 3 here would be possible denominators. One way I think about which way is which is I would really rather have a 1x cubed. That makes the problem easier. So if I divided by the 3, that puts it in a denominator. So according to the root theorem, the leading coefficient, the 3, gives us possible denominators. So factors of 3 are 1 or 3 here. The ending coefficient, the 2, gives us possible numerators. So factors of 2 are 1 or 2. So usually I write it down like this. My possible numerators are 1 or 2. Possible denominators are 1 or 3, and then I could have plus or minus any of those. So when I start with 1, divided by 1 is 1, and I could have plus or minus that. I could have 1/3 plus or minus. I could have 2 over 1, which is 2 or negative 2, and I could have 2 over 3, which is 2/3 or negative 2/3. So then I could start using synthetic division and dividing one at a time with each of these guys till I find 0 remainders, or I could look at my calculator to get a quicker idea of what it is, and then check. Oops, wrong button. So I graph this on Wolfram Alpha, and according to the graph it looks like -1, 2, and possibly 1/3 are the roots. So from here I try one. So I'm going to try -1 first. And so I write the coefficients of the original, 4, -4, -5, and 2. Bring down the 3, times -1 is -3. Add, get -7, times -1 is 7. Add, you get 2, times -1 is -2, and the remainder is 0. Check. Now that means my original polynomial factors as x minus -1, which you could also write as x plus 1, times 3x squared minus 7x plus 2. Remember, synthetic division tells us the remaining factor. So we've got it broken down from a cubic to a quadratic. Now we could either try and factor this quadratic, if you're good at factoring, or you could use synthetic division again with one of the other possibilities, 1/3 or 2. I thought I'd try 1/3 to see how fractions work in synthetic division. So bring down the 3. 1/3 of 3 is 1. Add coming down, I get -6. 1/3 of -6 is -2. Add coming down, and I get a 0, which checks that 1/3 is a root here. It also tells me the remaining factor is 3x minus 6. Remember, when you use synthetic division, the end result is always 1 power less than what you started with. So since I started with a cube here, synthetic division gives me 3x squared. Since that's a 3x squared, synthetic division says that's a 3x. To finish it off, I just take 3x minus 6 instead of equal to 0, and I get x equals 2, the last root. Pretty cool, huh? Alright, let's look at one more example. Let's see. Let's try, I'm just going to make one up, which could be dangerous. Oh, come on, pen. Y equals, how about 2x cubed minus 3x squared plus 4x and minus 6. So according to synthetic division, factors of 6 will give me my numerator. So I'm going to write down possible. Supposed to be s's, roots, and so it's going to be plus or minus. Numerator could be 1, 2, 3, or 6. Those are all the numbers that go into 6. 2, imagine dividing that out, that's my possible denominators, 1 or 2. So that means my possible roots could be something like x equals 1 over 1 or -1. 1 over 2, or negative 1/2. So there's going to be a lot of them here, right? 4 on the top, 2 on the bottom is going to give me 4 times 2 or 8 possibilities. Move over to 2 over 1, plus or minus. Now 2 over 2 is 1, so I've got that covered. So sometimes there are repeats. 3 over 1, or negative 3. 3 over 2, or negative. You could write that as 1.5 or 1.5. That doesn't matter much. Let's see, did the 3. 6 over 1, or negative. 6 over 2 is 3, which I already have covered. So there weren't quite as many as I thought originally, which isn't too bad. So if there are rational roots for this, it's got to be one of these numbers right here. So let's see, let's take a look at the graph. 2 minus 3 plus 4 minus 6 to narrow it down a little bit. So I'm going to go ask Wolfram Alpha to graph that for me. So I've got 2x raised to the third minus 3x raised to the second plus 4x minus 6. Go. Alright, it looks like 3/2 is my only rational root. Let's check it out. So if we use synthetic division with 3/2, 2 minus 3, 4 minus 6. I like to switch colors when I do this. Bring down the 2. 3/2 times 2 is 3. Add, get 0. Multiply, you still get 0. Add, you get 4. 3/2 times 4 is 6. Add, you get 0. Now that also tells me the remaining, so that's a check, right? This is a root because the remainder is 0. The remaining factor is then 2x squared plus no x's plus 4. Okay, so this thing factors, this thing up here, oops, did I lose that? There we go, as 2x squared plus 4 times x minus 3/2. When you do this, you always want to make sure if you multiply these, you get the right coefficient in front, because sometimes it's easy to lose track of the leading coefficient. But 2x squared times x is 2x cubed. So multiplying that out should give you that back. If you were to set 2x squared plus 4 equal to 0, well, you would subtract the 4 to the other side, then divide by 2. You get x squared equals negative 2. And that's a problem because that would mean you're going to take the square root of both sides, and the square root of a negative means I is going to pop up. So you would get I times the square root of 2. Square root of 2 is alright, but the I you can't graph, which means the other two roots of this are complex, and complex roots can't be graphed. So this only has one visible x-intercept, which we saw from the graph, and that's 3/2. But we can factor it. Here we have it factored as an irreducible quadratic. We could also factor that using the I square root of 2, and that would look like this. Let's get another page. Let's see. I'll write it under here. Let's erase this. Often when you write it with linear factors, red, you lose your coefficient in front. You'll see, so I have one factor, x minus 3/2. From this right here, oops, I forgot my plus or minus. Whenever you take the square root of a square, you've got to put a plus or minus on the other side. So then I'll have x minus the plus version, I square root of 2. And then I'll have x minus negative that, which would be x plus I square root of 2. And notice when I did that, I dropped that 2 out front. It disappeared accidentally, so I need to multiply it in here. So if you were to multiply out these four things, you will get the blue thing. back. So these are linear factors. This factor right here, the bottom, the 2x squared plus 4, that's called an irreducible quadratic. That means it can't be factored with whole numbers or fractions. You have to use I and square roots to factor it. So that's about it. The main point here was just illustrating what the rational root theorem tells us possible rational roots are. Rational roots are whole numbers or fractions where this thing strikes the x-axis. And the only one we get here is 3/2. Alright, that's it for this one. Bye-bye.